Introducing Traceless, a superior, super wetting glass cleaner. This video shows the attributes we considered and tested in the development of Traceless: wetting power on glass, cleaning efficiency on stubborn, oily, and mixed grime, ability to transfer the suspended dirt into a cloth, reduction of any residue from the glass cleaner, any negative effect on glass treatments, surrounding trim, and intentionally applied coatings. Our advanced goniometer accurately measures contact angles and surface tension. To establish a control measurement, we determined that the contact angle of distilled water, a pour wetter, is 107 degrees on this surface. We deposit 10 drops of each competitor to compare their wetting power. Here, competitor 2, from the United States, produces an average contact angle of 85.9 degrees. In contrast, Traceless's superior performance is demonstrated by a contact angle of 45.6 degrees. Higher wetting power is shown by flatter beads with lower contact angles. The measured contact angles are shown in this table, arranged from highest to lowest wetting power. Bilt Hamber's proprietary volatile surfactants increase Traceless's wetting power compared to competitors from between 7 and 85%. This is remarkable, considering Bilt Hamber's surfactants are 100% volatile and give zero residue. The significance of increased wetting power is demonstrated in the following cleaning tests. Here we compare Traceless's cleaning power to the competitors. A glass panel contaminated with fully cured permanent marker pen is held at an angle of 75 degrees. Using an automatic pipette with the tips held against the surface, we deliver a 300 microliter dose of each competitor. Here we see the comparative abilities of the glass cleaners to disrupt this tenacious film. Using the same method, we tested the cleaners against a cured bitumen film, where Traceless, again, outperforms the global competition. Note here, in these tests, only products with powerful wetting are able to cling to the repellent dirt film. Low wetting competitors simply run ineffectually downwards, in some cases dripping from the surface. The combination of excellent wetting and superior dirt film disruption is clearly demonstrated. Only Traceless has lifted the bitumen film. Even on unsoiled glass, the same low wetting products still run rapidly downwards. Our laboratory test on intensely illuminated glass shows this effect. Here we apply low wetting competitors to the left and Traceless on the right. The low wetting competitors simply run down the glass in rivulets, whereas Traceless superwets the surface, creating a uniform film of powerful cleaner. Spray-on wipe-off glass cleaners employ mechanical action imparted by a cloth or absorbent material. To reliably emulate this, we use scrub test equipment. A tenacious mixture of wax, oil, and particulate dirt is applied uniformly using a bar coater and allowed to cure. 3 milliliters of each cleaner is evenly distributed to the absorbent wiping surface. The scrub tester is set to deliver an even pressure at a consistent speed over a set number of passes. A visual comparison is made, noting the reduction of dirt film between competing cleaners. The test is repeated to include all competitors. Once more, Traceless provides dramatically superior performance, even in the absence of traditional powerful surfactants used by its competitors. In this test, standardized cotton discs, similar to those used in the ISO 8022 wetting test are dropped into a 1-liter measuring cylinder. The sinking point is precisely timed. This test quantifies how quickly the glass cleaner is absorbed. Without fast absorption, dirt is simply wiped around the glass surface rather than being removed into the cloth. Here we compare traceless to competitor 8 in the center and competitor 1 to the right. The fast wetting speed of traceless is easily observed. The performance of the American formulation would provide adequate glass cleaning speed. In contrast, the German formulation shows poor performance, only sinking the cotton disc after more than 3 minutes. Working speed would be very slow. Both competitor 8 and 1 contain traditional residue-forming surfactants. Polished glass plates are internally lit, giving a characteristic green glow. The powerful lighting amplifies any defects and contamination on the surface. A trigger spray application is made centrally and allowed to fully dry. From this, we can assess residue level. Some competitors deposit greasy residue whilst others form hard or spotty films. We have wiped through the center of the residue with 3 passes using a lint-free, suede microfiber cloth. Traceless, leaves no stubborn surfactant residue. 4 drops of each glass cleaner are applied to an aluminium plate. This material is commonly used for highly finished trim. After drying, we can see the characteristic residue left by the competing formulations, while traceless is clear. After buffing, it can be observed which formulations chemically mark the surface. We grade these using red plus symbols, from no pluses for 0 marking up to 3 for pronounced etching. Here we summarize the performance of each glass cleaner in the categories shown in this presentation. Traceless, a super wetting glass cleaner.